Hello viewers, myself Amarendra Reddy from Electrical and Electronics Engineering Department. So here again we are coming with some different kind of questions from the circuit theory or electrical network. So questions are really useful for your exam and definitely matches with your kind of standard generally asked by the what TSPSC. Means it is valid for both AEE as well as even other kind of exams by the what TSPSC. Okay, right? So now if you observe these questions, you will understand that how these questions are really useful for our exam point of view. So please utilize this opportunity here. Right? Now let us move on to these questions one by one. As I mentioned already, generally questions if you see from this TSPSC, okay, right, they ask what majority of the questions like from statements point of view, and which statement is correct, which statement is not correct. Means even though we know the concept here, where we do mistake means, as I said here, what we have, which statement is incorrect. Don't be in a hurry, okay, right, while reading the word question here. So you should be very cool and calm when you are writing the exam. So when you clearly observe that whether it is correct or not, just go through the statements, then you can easily answer. There won't be any typical kind of questions, but we only do mistakes, okay, right or not. Ultimately, if you see in the exam, we do mistakes, okay, right, because questions seems to be, means when you are out of the exam and if you see the questions, you feel that every question is what easier one only, right or not. Are you understanding? Are you listening my point, okay, right? So if you are cool and calm, if you have enough revision, automatically, so when you have clarity on each and every concept, then it becomes what very easy here in the exam, then you won't do any mistake. So when we are in a hurry and when we are not revising in a proper manner, definitely we get confusion in choosing the word statements. That is a mistake we do, okay. So anyway, as I said, okay, right, let us move on to these questions, have some revision and just recollect the word concepts. If you don't know, you just follow with the concepts. Are you getting my point? Okay. So now move on to the statements here. Which of the following statements is not correct, is saying. So superposition theorem is useful for linear and non-linear circuit analysis when several sources are present in the circuit. That is a statement. Thevenin's equivalent network, okay, Thevenin's equivalent network consists of one voltage source in series with the impedance. Norton's equivalent network consists of one current source in parallel with the impedance, okay, right. When both load and source impedance are purely resistive, maximum power is transferred or achieved under the condition load resistance is equal to source resistance. If you observe here, this is the statement of maximum power transfer theorem and this is the word Norton's theorem, right, and this is the what statement of Thevenin's. Statements only they given, and first one is not a statement because superposition theorem, it is statement only, but not matching with our superposition theorem statement, because superposition theorem is valid only for linear network, not valid for non-linear circuits, but he mentioned for both linear and non-linear. So definitely, so what must be the what incorrect statement, means this must be the what incorrect statement. So first option is what wrong with respect to the what question what they asked here, right, understood. So statements they given from our theorems and they are asking what which is incorrect, means first one is incorrect. Now move on to the next question here. If you observe, this is a question related to maximum power only. Assuming both voltage sources are in phase, the value of R at which maximum power is transferred from circuit A to circuit B. You can answer this question in two different ways, okay. So observe here, when that maximum power is transferred from source to load or circuit A to circuit B, here resistance is 2. So whenever equivalent resistance is what, same 2 ohms, then only maximum power will be transferred. Or then what must be the voltage here? What must be the voltage? 10 volts divide equally for 2 and 2 means voltage is how much given to that? 5. Okay, 5 volts is given to that, right or not? Now 5 volts is given to the second circuit means what must be the current here? Current I is equal to, current is flowing from 5 minus 3, okay, by its resistance is what? R, right or not? What must be the current here? Tell me. What must be the current? So when it is in phase with that, so what must be the current? Okay, voltage 5 minus 3 by R will be the what? Current we are saying. And if you are able to find the what? Current. How to get the what? Current? Current is what? How much it is? Okay. Current if you find, okay, right? The current, how much we get? So as I said, okay, here equivalent load resistance is what? 2 ohms. So 5 minus 3, okay, 2 volts, 2 volts by the what? Resistance. What must be the resistance? Same thing we are writing, right? So R we need to have, R is equal to, how much we get? That 5 means we need to have that current, how much here? 2 amperes we have, okay, or how much voltage we get here? 2.5 by what we are saying? 2 volts, okay, not in that way. If you just look into that statement once again, power is transferred from circuit A to circuit B. If you observe that, how that voltage distribution takes place here, if you follow with the current version, okay, right, what must be the current here? 5 by 2. 5 by 2 means what will be the current flowing here? 2.5, okay, and how much voltage you have? How much voltage means how much? V is equal to 2 only, right? So V is equal to 5 minus 3 means V is equal to 2. So current, you know, V by I means 2 by 2.5 means we get what? 0.8 ohms. That is what? Resistance. Otherwise, suppose if you are not getting this properly, what we do here? What is another method? But this becomes what? Lengthy procedure. I am using another color here in this. What we do here? We assumed that same voltage which we applied here, and current is what? I. So power is what? Product of voltage and current. What is the voltage here? Voltage, if you see, V is equal to 10 minus 3 by, what is the total? 10 minus 3 is how much here? 10 minus 3, 7, okay, or otherwise you can say in this way, okay, right, we will not be explaining in this fashion for this, okay, right. So voltage means I am talking about if it is delivering the current I, so 10 minus only 2I we need to take. This is what voltage expression. And what is the current here? I is equal to 10 minus 3 by R plus 2, right or not? R plus 2. Voltage, current, both you got. Product of voltage and current will give the power. Differentiate the power with respect to R, equate it to 0. Then we get the value of R is equal to 0.8. Both ways you can answer, okay, right? You can match with the any kind of what will say method here. You can use any one of this method to have this. So what must be the right answer here? To have maximum power from circuit A to circuit B. Understood, okay, right? Move on to the next one. What we get here, for the circuit shown below, Norton's current and the resistance across A and B terminals. If you see resistance across A and B terminals means you have to deactivate these. What must be the Norton's here? Both are connected, okay, 3 and 6 both are connected in parallel, and it is in series with what? So how much we get? 3 into 6 by 3 plus 6 means 18 by 9 means 2 plus 3. So Norton's resistance is what? 5 ohms. But two options are there. So you have to even find, you should find even Norton's current. When you want Norton's current here, first you find this what voltage here, node voltage if you do. Otherwise you can use some different methods also, right? Nodal method, if you use, assume all the current are away from this. Voltage by the 3 ohms will give the what? Norton's current. Now move on to this calculation of what? Norton's current. V minus 20 by its resistance what? 3, and next V minus of minus 10 by 6, and next one is what? V minus 0 by 3 is equal to 0. Now if you simplify V, we will get voltage, we will get automatically Norton's current means V by 3. So if you simplify, we get what? 2 amperes, I think, okay. 2 amperes we get after finding voltage, means we will get what? 6 volts. So 6 by 3 means 2 amperes. So which one is matching? 2 amperes with what? 5 volts is the what? Correct option for this question here. Next move on to the what? Another question here. Here impedance is given as what? 20 minus J10 ohms. Observe here. Means it must be what? Resistance, and it must be what? Capacitive reactance, right or not? What is making? If the frequency is doubled, if frequency is double, what will be the new value of the what we say? Impedance is asking. How it changes? Resistance is what? Independent of frequency. So it will not change. So R means R, whatever, whether it is doubled or not. Xc, if you see, what is Xc is equal to 1 by omega c, right or not? What is the meaning? If frequency is what? Doubled, what will happen? 1 by 2 omega c, then capacitive reactance what? It reduced by what? How many times? By 2 times it is reduced. Means R new value is how much here? Resistance will be same 20. But capacitive reactance what? Decreases, okay, right? Minus Z10 means minus Z10 by 2 you have to do, because frequency is double. So what is the new impedance here? 20 minus Z5. This is the impact. If it is inductive reactance XL means what we get? Omega L means it is directly proportional to frequency. Inverse relation, so frequency doubled means capacitive reactance becomes what? Half, or 1 by 2 times. So which one is matching with our result? 20 minus A5 means this must be the what? Correct one. Next question, if you see, relation between resonant frequency and the what? Half power frequencies. If you see that, this is the what? Kind of frequency response, okay, for the what? Series resonance circuit, okay, right? Current is maximum at what? Maximum at what? Resonant frequency F0, and current is what? 1 by root 2 times of maximum value at what? Cutoff frequencies. That is what? Lower cutoff frequency or what? Upper cutoff frequency. We call them as what? F1 and F2 are what? Cutoff frequencies. Cutoff frequencies, or what we call this? Half power frequencies. Half power frequencies. We even call them as what? 3 dB frequency. All are different names, okay? 3 dB frequencies. Understood? And if you observe the what response also here, how we get, this is the what kind of response we get. Now, if you observe from the frequency response, F naught is what geometric mean of two cutoff frequencies or half power frequencies or 3 dB frequencies. So, which one is the right option here? So, resonant frequency is the what? Geometric mean of two cutoff frequencies or corner frequencies. That is from our resonance topic we are saying here. Okay. Let us move on to the what next question here. In a balanced 3-phase star connection system, the phase difference between the what line and phase voltage. Okay. If you notice, this one is repeated so many times, okay, right? So, observe this question carefully. What we are saying? Star connection, okay. Star connection, if you see, these are the what phase voltages we are taking, all are equal and displaced by what 120 degrees, VR, Vy, Vb. So, what we are saying? Phase displacement is how much here? 120 degrees in between what these two quantities. We are talking about what line voltage. Line voltage means it could be what VRY or VYB or VRB. We call these are what line voltages. This is what VR minus Vy, Vy minus Vb. Okay, phase displacement. Sorry, voltage difference between this, and VR, Vy, Vb. All these are what like Vn. We call them as what? Phase voltages, phase voltages, and these are what line voltages, right? So, now if I draw for the line voltage with this color, look at that. Suppose if I talk about what VR and VRY, what will be the phase angle difference, right? VRY means what we are saying here, or you can have anything, okay. VRB also you can take any one of this, okay. VB if I extend into another side, okay, understood. This one will be our minus VB. Minus VB means total 120 divides into what 60 degrees, and this one is what 60 degrees. Now, VRB means phasor sum of these two, right? I am going with parallelogram method. When I add these two, this one will be our what we are saying. This one is our this one is our VRB. VRB divide that what 60 degrees into what 30, and this one is what 30. Okay. So, the phase difference between line and phase, okay, this is phase and this is what line. What is the phase angle difference we got? 30 degrees. Okay, phase angle difference between the line and phase is how much we got? 30 degrees is the result, right? Next, move on to the another question here. In series, sorry, not in series, in RLC circuit, current at resonance is talking about maximum minimum in both series as well as what parallel resonance circuit. Look at here, how you write series circuit means series, you write all the elements like RLC in what series here. What will be the impedance here? Z is equal to R plus J into XL minus what? XC. This is about what series circuit. At resonance, what we are saying? At resonance, XL is equal to XC. Means this becomes what 0, means Z becomes only R, means Z becomes what minimum. Impedance is minimum, means what will be the current? I is equal to V by Z. Minimum means what must be the current? Current becomes what? Maximum. So, at resonance in series circuit, current is what? Maximum. Maximum in series resonance is the what? Correct up to now. Okay, we don't know about parallel, now we see for the what? Parallel. So, parallel circuit, if you say How we connect the elements? All the 3 elements we connect in what? Parallel. So, if you go with that kind of so whenever elements connect in parallel, we talk about what? Admittance. What will be the admittance? We write 1 by R means G plus J into BC minus BL we will get. Means at resonance in parallel circuit, BC is equal to BL we will get. Means admittance becomes what? Minimum, which is equal to Z. How to find current from admittance? I is equal to V into Y minimum. So, if admittance is minimum, current is also minimum. So, what is the observation here? Observation is what? At resonance in series circuit, current is what? Maximum, means maximum in series resonance and minimum in what? Parallel resonance is the what? Correct statement, okay, among these 3, among 4 options, right or not? So, this is the way to identify the what statement, okay. Such questions are having good priority in these kind of exams, okay, where we generally do the what? Mistake in the confusion, okay. Move on to the next question here. What is the question here? Following circuit resonate at what frequency, right? So, one thing we have to do, at resonance Z is equal to R plus J XL minus XC, or if you write even in the form of admittance also G plus J into BC minus BL. At resonance there won't be any reactive part, means there won't be any imaginary part. Definitely impedance or admittance must be what? Purely real part we get. So, you write either impedance or admittance for the given circuit, whichever is what? Easy for us. Equate the what? Imaginary part to 0, which gives what? Our resonant frequency. That is the strategy for this. So, suppose if I write what is the impedance for this connection, okay. Impedance if I write 10 is in series with what? Again parallel combination of what? Capacitance means 1 by J omega means omega C means what? C is 1 only. This is in parallel with what? J omega, okay, J omega and 4 J omega L is in series with what? 1 by J omega C. So, if you observe here, okay, then 10 plus 1 by J omega is in parallel means J 4 omega, again 1 parallel, right? Series only, series. These are series and this one is parallel. So, now Z1 Z2 by Z1 plus, so plus J 4 omega plus 1 by J omega, 1 by J omega, right. If you simplify and equate the imaginary part to 0, we get omega is equal to 1 by 2 radians per second, or it is equivalent to what? 0.5 radians per second. So, which one is matching? If you equate the imaginary part to 0, we will get this what? Result. So, whether it is series connection or parallel, whatever it is, you write your convenient impedance or admittance for the given circuit and equate the imaginary part to what? 0, so that you can have the what? Value for the resonant frequency. Understood? This is the strategy we need to apply for these kind of questions. Move on to the next question here. What is the question here? The number of chords. What is another name for the word chords? We even call them as what? Links or chords. Graph. Okay, if you identify what are the total branches here? 1, 2, 3, 4, 5, 6. Okay. Branches I am indicating with what? B. So, 6 number of branches are there. What about nodes here? 1, okay, like D. I am giving notation for what? Each and every node here. If you follow with that, A, B, C. Okay, number of nodes is equal to 4. We have a relation, okay, for the links. L is equal to links or chords. So, what is the relation? L is equal to B minus of n minus 1 or B minus n plus 1. You can use any one of this relation. So, 6 minus 4 plus 1 or 6 minus of 4 minus 1. If you simplify, 3 links or what, 3 cards we get. So which option is correct? So most famous question from the word graph theory, number of links or cards will be how much here? 3 only will get. Now move on to the next question here. Two-port network is given here, I1 and I2, and they are asking what impedance parameter. Here directly you can get admittance. You can do in two different ways, okay, right? I1, I2 is expressed in terms of, if I write in the form of matrix, okay, right? 2, 1, 1, 1, and this one is what? V1, V2. So this is like I is equal to admittance, okay? Admittance, when you know how to get impedance, inverse of what admittance will give that. So A, B, C, D you have. A, B, C, D means how to get inverse of A, B, C, D? 1 by AD minus BC into D minus B minus C A. You follow with that. So inverse of what? 2, 1, 1, 1 inverse. If you find what we get, 1 by AD minus BC, 1 by AD, 2 into 1 minus 1 into 1, 2 minus 1 means 1 only. So AD minus BC is 1, no impact on this. Directly D means 1, D minus B minus C A if you write, okay. These are what? Impedance parameters. So Z11 is equal to 1 ohm, Z12 or Z21 is equal to minus 1, Z22 is equal to 2, wherever these options are there. So it is easier way, or otherwise you can convert. Anyway, we got answer in short time. 1 minus 1 minus 1 2 is the what right option for this, okay. Same thing, how you can solve in another way, you can convert, okay. I1 is equal to 2V1 plus V2, okay. So again I2 is equal to V1 plus V2. Try to express V1 V2 in terms of the what I1 I2, means try to just reform this, okay, reconstruct V1 V2 in terms of I1 I2, then you will get directly. You can use any one of whichever you feel comfort, whichever you, some people feel that finding inverse of a matrix is easy, follow with that. Otherwise you can just play with the equations, then you will get the answer. Use any one of this, then this must be the what result. Understood? This is the what answer. So matching with our second option here. Next question, if you follow here, transfer function is asking here. So and again options, if you see in S domain, resistance will be resistance, there won't be any change, okay, that is 1 only. Capacitance we write it as 1 by Cs, means 1 by S into C value is what? 1. So here what is the input? V1 of t becomes what? V1 of S. V2 of t becomes what? V2 of S. So now ratio of V2 to V1 means trans function only is asking. V2 of by V1 of S means it is like you can use KVL and find like this, or it is like Z1 Z2. So output impedance Z2 of S by Z1 of S plus Z2 of S, like this you can use. So output impedance is 1 by S, total circuit impedance 1 plus 1 by S. Simplify further, 1 by S by S plus 1 by S will get cancelled. What is the result? 1 by S plus 1 is the trans function for the what given network. So which one is matching for that? A is the what or first option is what matching with our result. Let us move on to the next question here. The value of H22. So here for two-port network parameter, I don't suggest you to memorize the what relations. Just stick on to the what dependent independent. H parameters means V1 I2 are what dependent, then you get the what H11, H12, H21, H22, right, and here it is what I1 and V2. So when you find, okay, these first two you will find when you make V2 0, second two you will find when you make what I1 0, then what we get? H22 only is asking, right? H22 is equal to what we get? I2 by V2, right or not? I2 by V2 when you make what? I1 0. I1 is what? open circuit. When you make it open circuit, I1 is equal to 0. I1 is 0 means what is 300 I1? This is also 0. I2 is also 0. 0 by something V2 means it must be what 0 only. So 0 is the what right now. Like this you can easily do by just going with open circuit and short circuit instead of memorizing the what relations. You memorize only dependent and what independent variables. That is the best strategy for what two-port network parameters, right? Understood? This is the way you should have a practice. Are you understanding? So please utilize this opportunity. Okay. So if you want to crack this, okay, you need some guidance support like this. So for that we are providing. So you please follow with these details and try to utilize this opportunity, right? All the best for your exam, okay, which is going to happening on this what 22nd Jan. Okay, please utilize this. Thank you.